Oh, hey guys. We are keeping on trucking. All right, we're in chapter 7. Sorry, chapter 6. My bad. Where we understand similar figures. We started talking about this last couple of days when we started talking about dilations. Remember, dilation is when you have a change in size, right? So it's a transformation that has a change in size. So you have non-congruent figures. You have similar figures. And remember, similar means same shape but different sizes, right? Now, we can actually get a little bit more technical than saying different sizes, right? Because Jet's outside. Rather than saying different sizes, you want to actually say that the sides are in the same proportion, right? So basically, you're multiplying each side by the same scale factor. Whether it's an enlargement or a reduction, basically each side kind of matches to the corresponding size on either the smaller or larger figure. So that's the proportionality of it right there, right? But it's still going to be the same shape. So Andrew draws the two figures shown on the coordinate plane. How are the two figures alike? How are they different? How do you know? Well, we have this on a grid, so it's very easy to actually measure this kind of stuff, right? We've got A matching to B, A going to B, and that's 4 this way. Then A prime to B prime is actually 2, so that's good, right? We can see that those are in proportion, or it can be in proportion, right? Because you could take 4 and you could multiply it by 1/2 to get to 2, right? And then let's use a different color here. We've got B to C as, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12 across there. So then if it's going to be in proportion, we're going to multiply that side by the same number that we multiplied the other two sides, right? So 4 times 1/2 is 2, 12 times 1/2 is 6. So if these are similar triangles, we should expect that this side should be 6 long, right? So let's figure it out. 1, 2, 3, 4, 5, 6. Perfect, right? So we've got these two sides. We can see that it's a right triangle because it lines up exactly with the grid. We actually have not discussed this yet, but you can actually measure this side. You can figure out the exact length of that size using the Pythagorean theorem, which will actually be in chapter 7, so the next chapter after that. And we can see that this side is this side, A prime to C prime, is half as big as A to C. So how are the two figures alike? Well, we've done this T-chart before, right? Okay, so on the alike side, they are the same shape, right? They're both right triangles. Okay, and on the different sides, they're the same size, right? But again, they're in proportion. So alike in that they're the same shape, different in that they're different sizes, right? And technically, they're in the same proportion, or each side is in the same proportion as the other sides. So yeah, how do you know? Well, we know because we measured and compared the sides. Okay, one other thing that we can introduce here is the similarity symbol, okay, or how to write a similarity statement, okay? So we have triangle ABC, so this is kind of how you do this, triangle A, B, C. We have triangle A prime, B prime, C prime. If they were congruent, right, we would use that like the wave with the equal sign underneath. But since they're not congruent, we can use the similarity sign, which is just the wave, right? So that's how you write a similarity statement saying that these two triangles are similar. And again, similar means that they're the same shape, but the sides are in proportion to each other. So, okay, we've got this kid Albert. E graphs trapezoid ABCD, kind of the blue one right here, and trapezoid GHJK, the orange one kind of underneath. How can he tell whether the trapezoids are similar if you can map one figure to the other by a sequence of rotations, reflections, translations, and dilations? How can you tell? Oh man, I'm gonna have to change that on the on the one I print for everybody. So basically, we're going to figure out if we can get this triangle to this triangle by doing a sequence of transformations, so more than one transformation. Obviously, we know we're going to have to do a dilation, and it looks like we're probably going to have to do a reflection as well. So if let me do blue because that's a blue triangle, right? I've got A, B, C, D, right? A is at, let's see, -3, 6, -3, 6, okay? B is at 2, 2, 3, 4, 5. So well, clearly it's 2. Come on. C is at 2, 2, over 2 and up 2. And D is at, let's see, -1, 2, 3, 4, 5, 6, +2. So we've got our original shape right there. Clearly, we're going to have to shrink it. And we're going to have to dilate it. So let's figure out how much we should dilate it by. This side is 4. That side is 2. So it's pretty easy to figure out that you're multiplying this one by a half, right? So if we multiply each of these by a half, is that -3/6? That is -3/6. Okay, good, because that's actually kind of right in the middle there. Okay, so that's actually going to give us a decimal right there, but that's okay. Okay, so A prime is -1.53. B prime is 1, 3. C prime is 1, 1. And D prime is -3, 1. Okay, so what we're going to do is plot these points, right? So -1.53 is going to be our A prime. So let's see, -1, and then halfway across, and then up 1, 2, 3. So that's our A prime right there. B is 1, 3, so over 1, up 3. Okay. C is 1, 1, so right there. C prime, sorry. And then -3, 1, left 3, and up 1 for D prime right there. So we've got our similar triangle right here. Okay, so we can see that we've shrunk it down, right? And then it looks like it's a reflection across the x-axis because like each point is the same distance away from the line of reflection. So we've got a reflection. So if we're going to write it out, so how can he tell, right? Well, he could perform, I'm just going to write that down here. He could perform a dilation with a scale factor of 1/2 and a reflection across the x-axis. Okay. Yeah. Technically, let's see. Technically, you could actually do the reflection first and then the dilation to get it to kind of map on there. Yeah, you could do either one, but the graph isn't big enough for us to do the reflection first. So we got to do the dilation first. Now, one thing I do want you guys to realize, the order that you kind of list your letters is important. Typically, it will be in alphabetical order, right? A, B, C, D, and G, H, J, K. We're missing an I in there. Anyway, the order is important, right? Because we can see that A matches to G, which makes sense, right? A is going to match to that G right there after we reflect it, okay? And then B matches to H, B matches to H, C matches to J, right? C matches to J, C to J, and then D to K right there. So that is an important thing to notice and realize that the order of the letters when you kind of write this are important, right? And if we were going to write a similarity statement about this, I would say that, trapezoid, and let's say trap ABCD is similar to trapezoid GHJK. I think they skipped the I because I looks like 1 or L. Oh, yeah. Okay. Next one. So we've got triangle ABC and then triangle A prime, B prime, C prime, and we're going to determine whether they are similar to each other. Okay. So this is kind of where the order of this happens. Okay. So we can see that B matches to B prime clearly, right? And A to A prime and C to C. This should be a C prime. I think I cut this off when I copied it. That should be a C prime right there. Sorry. So what we can do is we can set up a series of ratios to see if we get the same number. And if we get the same number, that's the scale factor that you use to multiply to get from one to the other, right? So from the small one to the big one. So we know that it's an enlargement because we're going from the original here, the pre-image, to a larger image, right? So we know it's going to be an enlargement. So when we set up our ratios, we want to make sure that the original is on the bottom and the new one is on top because that'll give us the right scale factor. Okay. So this is going to be a little tedious to set up, but like I can match AB, the side AB, right? Actually, sorry, my bad. I can match A prime B prime to AB, okay, and then it should be equal to, right? Let's see, we'll do B prime to C prime over B to C. Right? That's the matching side right there. Okay, let's actually do this right here, right? That matches to that. Okay. This matches to this, so I'll actually do this in blue to kind of match this up a little bit better. Okay. And then the final one, let's do this one in green, right? A prime, C prime, and then A to C. So we're going to just be doing some division to set this up here. So let's see, A prime, B prime is 27, divided by A to B is 12. Okay. B prime, C prime, it's going to be the same thing, right? Shoot, that should be in red. Come on, Wishart, you're better than this. Okay, that should be in red. Sorry about that, guys. And then the last one, right, is going to be this 18 divided by 8. Okay, and so the idea here is that if these are similar, we're going to get the same answer for these kind of division problems, right? 27 divided by 12. Boom is going to give us 2.25. Okay. We know that's going to give us the same thing, so we can just say 2.25 right there. And then 18 divided by 8 is, should, if they're similar, give us the same answer. So 2.25. So we have the scale factor right here. Yeah, so that's a lot of work to kind of set this up. You don't necessarily need to do all that work. I just kind of wanted to show you what I'm doing, right? I'm comparing the sides from the new one to the corresponding side on the old one, right? Or the original, right? Really all you have to do is do a little bit of division, like just like match one of them up. You can even do it in your head. You can say, well, I know this one's going to match to that one. So I just do that math right there. 27 divided by 12. So it gives me 2.25. And then all I can do is I can just double check the other ones, right? I can say, well, 2.25 times 8 should give me 18. Boom. And then I know those are going to match up, right? So it's a lot of math right there to kind of show you how to set it up. But in reality, you don't actually have to show that much work, right? You just have to understand how to kind of mash the sides up, right? Yeah, I don't know. Hopefully that made sense. Oh, Mr. Wishart, you're the living end. All right. So we're going to complete a similarity transformation here. This is just a sequence of transformations, right? We have quadrilateral JKLM right here is in quadrant 4. I've got the points right here for it already. We're going to graph J double prime, K double prime, L double prime, M double prime, the image of that original by a dilation. Man, there's a lot of typos in this here. Okay, with center 0, 0 and a scale factor 3 and a reflection across the y-axis. So we have a dilation here and we have a reflection. So dilation, scale factor of 3. We're going to take each of these points and multiply by 3. Okay. Sorry, this news. And that's going to give us our kind of middle shape right there, that J prime, K prime, L prime, M prime, right? So we multiply each of these by 3. I'm going to do this in blue. That's going to give us 6, negative 3. Okay. 3, negative 6. Did I get the right? 1, negative 2, 2, negative 1. Yes. There we go. Okay, I don't know what I was thinking. 2, negative 6. 3, negative 6, actually. 3, negative 9, my bad. 3, negative 9. Yes, and then 9, negative 6. Okay. So then we plot these points, right? 6, -3 is going to go out to 6 and down to 3 right there. That's our J prime. Okay. Label as you go. It's a lot easier to label as you go rather than try to label at the end, right? K prime is 3, -6. So over 3, down 6. K prime, 3, -9, over to 3, and then down to -9. That's our L prime. And then M prime is 9, -6, right there. And so we have our dilation with a scale factor of 3 complete, right? Use a ruler to make sure your edges are straight, right? You guys are in 8th grade. You should know by now how to use a ruler to make your edges straight if you can't draw a straight line by hand, which I can't, so that's why I use a ruler. Okay, cool. So we have our shape here, our original, our pre-image. That's kind of our middle image right there. And oh, one thing I forgot to do on this last one, right? Is this the case? Yes, it is. And how you'd write that, triangle ABC is similar to triangle A prime, B prime, C prime. Sorry. All right, so we've got this shape right here. Now we're going to reflect it across the y-axis. The y-axis is the line going straight down the middle, right? Okay, and we can see that K prime is 3 away, so K double prime is going to be 3 away as well. L prime is 3 away, so it's going to kind of line up right there. M prime is, let's see, 8 away, so it'll be 8 away over here, right? And then J prime is 6 away. See, 1, 2, 3, 4. Yeah, 6 right there. Yeah, cool. And that's kind of how you do that sequence of transformations with the dilation, right? Just like every other one, you just kind of do them in order. Let me see. Could we have done this one in a different order? Could we have reflected first and then dilated? Yeah, it would have gotten you the same place if you had reflected and then dilated. Oh, that should be double prime. My bad. There you go. So yeah, we can see that quadrilateral JKLM is similar to quadrilateral. Ooh, man. I'm going to have to J prime, K prime, L prime, M. Sorry, double primes. Those should have all been double primes. Yeah, just like that. Ooh, yeah. Okay. Is ABCD similar to EFGH? Explain. Well, this is where we make sure that we can line up our, this should be trapezoid. Anyway, line up your A to E, B to F, C to G, and D to H, okay? So G to H, right here, is going to match up to C to D, okay? So G to H is 1, 2, 3, 4, right there. So and then we've got C to D is 1, 2, 3, 4, 5, 6, 7, 8. Okay, all right. We've got this one. It seems like they're in proportion so far, but let's double check. Okay, A to B is, let's see, 1, 2, 3, 4. Okay, and oh, I should be doing this in a different color. Let's do red. Okay, A to B is right there, and that's going to match to E to F. Okay, on the bottom, and that's 2 across right here. So we can see that these are in proportion, definitely, right, by 2. Okay, so if we're taking A, B, C, D, and we're kind of looks like it's reducing down here because if this is the original, this is the image, right? We're shrinking it. That would work out well right there, right? So we can say that our scale factor, or K, is 1/2, right? And that's our dilation right there. And we would actually end up doing a rotation, right? Because A matches to E. You can see that right there. And it would be like a 180-degree rotation. So you could do a dilation with a scale factor of 1/2 and a 180-degree rotation. Okay. And you'll say, yeah, ABCD is similar to EFGH, just like that. Okay, we're going to put this in our notebooks. Oh, I didn't even put my reference book in there. Let's see, this is going to be on page 56, 57. Skip the page in here. It's going to be in 57, so we're going to fold that in half. Okay. Then 57 will be 6-7. Understand similar figures. And I've got to put something in there in between, but don't worry about that. So understand similar figures, and we're good.